Let's resume practice questions of chapter 2. The next one on the list is question 2.7. So let's take a look at the question. It's Q 2.7. Find the accumulated value at time 15 years of regular payments of $50 made at times 5 years, 6 years, and so on, with the last payment at time 10 years. Use an annual effective interest rate of 16% and an annuity due. So we want to know the accumulated value at time 15 of regular payments, 5, 6, and so on, with the last payment at 10. Okay, with the last payment at time 10 years, using an annual effective interest rate of 16% and an annuity due. So it will be at the beginning of each year. So now what we want to know is, so here are the payments at 50. So they are the equal payments. Okay. First of all, you need to count how many payments do we have from 5 to 10. Right. So again, this is a small number, so you can easily count. The number is 6. So n is 6. The question asks us to use annuity due, but of course, you don't have to. You can think there's an annuity immediate if you want. So that means this is the payment running from 5 to 10. Okay. If you think this as an annuity immediate, then it goes from 4, right? But if you think this as an annuity due, it goes from the beginning of 6th year all the way to the beginning of 11th year. Okay. So let's follow the textbook suggestion. Let's think this as an annuity due. So when we consider annuity due, the future value, okay, so this is the value at n. Okay, that's when you have from 0 to n. But now when we start at 5. Okay, and the last payment is at 10. So what is your n? N is actually here, right? If you think this as an annuity due, then payments are always made at the beginning of each year, right? So if the last payment is made at time 10 years, so again, the convention is when we say at time 10 years, it is at the end of year 10. So at the end of year 10 means it's the beginning of year 11. So when we calculate, so when we write down 50 times the future value of 6 at 16%, the time point is here. So let me use a different color. So this is the account value at time 11 years. Because if we think this as an annuity due, the last payment is made at the beginning of that year. So the last payment is the beginning of the 11th year. And when we consider or when we use S, it always refers to the end of the annuity. So here the end of annuity is 11, not 10. Okay, so that's very important. So that's not what we want the value to be. We want the value to be at 15. So there is a little more work to do. there are 4 years between 11 and 15, right? Again, so 12, 13, 14. So 1, 2, 3, 4, right? Again, it's the end number minus the starting number. So that gives you the number of years. And this is the value we are looking for. So when you calculate, it's about $942.79. Okay, so that is the final result. Of course, you don't have to do this, right? The question says treat it as annuity due. You can treat it as annuity immediate if you want, right? So if you treat this as an annuity immediate, so what you have is so if you treat it as annuity immediate, the payments are always made at the end of the year. So if the last payment is at time 10 years, that is also the end of the story, right? So this is the payment at 10. So in that case, what would be the accumulation factor from 10 to 15? 1 plus I to the fifth, right? So of course you'll get the same result because the difference between annuity immediate and annuity due is 1 plus I, right? 1 year accumulation factor. Q 2.10. In this question, Mary receives payment of $100 at the beginning of each year, including today, forever. So we have a perpetuity. Virginia receives payments of X dollars at the end of each year, starting 5 years from today, forever. It's another perpetuity. The present values of their payments are the same at an annual effective interest rate of 10%. Calculate X. So that is the payment of Virginia will receive. So if you want, you can draw a quick timeline to help you understand. But at least for Mary, the case is simple, right? It's a perpetuity. It's a perpetuity due because it's paid at the beginning of each year, including today. So we have 100 times, it's an annuity due. So you're going to put double dots for A. This is a perpetuity. So you have infinity. And the interest rate is 10%. So this is the present value of Mary's perpetuity, okay? We're going to equate to the present value of Virginia's. Okay, Virginia also receives a perpetuity. So, and it's also a perpetuity at the end of each year. So it's a perpetuity immediate. The difference is this is deferred. In the Virginia's case, it's deferred for 5 years. Okay, so you will need to times by a discount factor of 5 years. Okay, so basically that is the analysis. So if you want to draw the graph for Virginia, so here's 5 years. Okay, starting from here, x goes forever. This is a perpetuity. Okay, because we treat this as a perpetuity immediate. So when we discount or when we calculate this, it's the value at time 5, because that is the beginning of this perpetuity immediate, right? And now we want everything to be discounted back at time 0. So I need to go back for 5 years. Okay, and that is reflected in this discounting factor. 1 year raised the power to the 5. So that's the discount factor for 5 years. The formula for perpetuity is rather easy. So you know, here is 100 divided by D. D is the discount. So it will be I 0.1 divided by 1 plus I is 1.1. Okay, so this is 1100. Equate to the right-hand side. Okay, right hand side is 1.1 negative 5 times x. So now you have a perpetuity immediate. So you divide by I is 0.1. Okay, so you should be able to figure this out, right? So this is you will get the x value. So please complete this. The next one is 2.13. Okay. Aaron pays 4,000 at time n years in order to receive 438.52 at the end of each year for n years, starting at time n plus 1. The annual effective rate of interest is 8% from n. This is more complicated than the previous one because the computation is not easy. So here we have Aaron. This guy pays. So let's say here is time n years. Pays 4,000 at this time. So after paying this amount, he will receive $438 plus 52 cents. Starting at time n plus 1 years for how long? For n years. So we know here we have n payments. Okay. We know the effective interest rate is 8%, but we don't know n. So now we have an equation. Actually, n, the actual n here doesn't matter, right? So what annual pays? So basically, in this question, Alan pays $4,000 to receive an annuity immediate without any deferral, right? So it's paid the same year. So you pay this at time 0, you receive it at the end of year 1. So this is no deferral. So we have present value 4,000, okay? And I know 438.1 is the payment, and this is annuity immediate. So basically the difficulty comes from solving this equation, right? So 1 minus 1.08 to negative n. So here, this number is the number of payments. Here, Aaron is going to receive n payments. So that's why here is n divided by the interest rate, which is 0.08. Okay, so to solve this, what I do is this will be 4,000 times 0.08 and divided by this 400 something. Okay, let's call this a constant c. So I use 1 minus c to get this. Okay, then I take log on both hand sides. So this negative n will come out. Okay, so what is n? N will be negative log 1 minus c divided by log 1.08. Okay, please complete this calculation. I give you the result. The result is 17. So make sure you are able to get 17. Let's do 2 more questions. I try to speed up a little. So 2.14, NASA pays 1,500 at time 10 years in order to receive 1,000 at time 11 years and 1,000 at time 12 years from the annual effective interest rate. So basically, if you have something this, well, let's call it simple because there are only 2 payments, right? So she pays at 10. How much? 1,500. She will receive 1,000 at 11 and 12th, right? So the present value is 1500. So the future value, this needs to discount back by 1 year. The second payment needs to be discounted back by 2 years. So this is pretty much everything, right? So this is a quadratic equation. So this question asks whether you are able to solve a quadratic equation. So let's divide by 1000. I get v squared plus v moves to this side. I get 1.5. So let's put it into fraction. So you should know the quadratic formula, right? How do you solve? So to a is 1. So here is ax squared plus bx plus c equals 0. So the solution is 2a negative b plus minus b squared minus 4ac. So here my a is 1, my b is also 1, so it's negative 1 plus minus, okay, b squared is 1 minus 4 times a times c. C is negative, so it becomes positive. Right? So obviously v is a positive number, so I will pick the positive value. So 6, right? So you can get the result, right? So it's about 21.5%. So 21.52%. So this is rather mathematical, right? This basically asks whether you are able to solve the quadratic equation. 2.15. So this is Michael pays 2,500 at time 0 in order to receive 400 at the end of each year for 7 years, with the first payment at the end of first year. He also receives a lump sum of 1,000 at time 8 years. Find the annual effective rate of interest that he earns on his money. Okay, so let's draw a timeline. Michael pays 2,500 at time 0 in order to receive 400 at the end of each year. At the end of each year, he will receive 400 for 7 years. So the last payment is at time 7 years. So there are 7 payments. Okay. He also receives a lump sum of 1,000 at time 8. So here is 1,000. Okay. Found the annual effective rate of interest that he earns. Okay. So the present value or the money outflow is 2,500. So now let's see what he receives. So first of all, it is an annuity immediate, right? Plus 1 lump sum payment. So it's v to the 8th power, okay? Of course, you can repackage this 1,000 into 400 and 600. Then you change this to 8, and here becomes 600. But you know, it's probably easier to keep it this way. The question now is how can we solve this question, right? So we know the present value is 1 minus 1 plus I to negative 7 divided by I. Here is 1,000 divided by 1 plus I to the 8th. Okay. So let's times by this factor on both sides. Okay. So then you will get 400 divided by I. So here becomes 1 plus I to the 8th minus 1 plus I plus 1,000. Of course, you can divide it by 100 on both sides to figure out. Okay, so let's do that. Cross 2 zeros. Okay, this both hand sides, we have it on both hand sides. So we have 25 minus 4 divided by I, 1 plus I to the 8th. Okay, and then we have plus 4 times 1 plus I divided by I equals 10. Okay, obviously we wouldn't be able to solve this question. So the usual way you do is you try, right? So if you try 10%, what do you get? You will get you will get a value which is I believe it's bigger. So you need to try smaller one. You will get a different value which hopefully is smaller, and then you know it will be between 9% and 10%. Technically, if you want, you can also apply the so-called linear interpolation. Okay, so that is something you don't technically need to learn. So I don't do that here. For instance, what I mean is you can, if you look at this equation, okay, so you know when I goes up, the value will go down. So if you try I equals 10%, let's say the right hand side is my calculation shows is 2,413.87. Okay, this is less than what I want. So in order to get 2,500, I need to reduce this interest rate. So let's go down by 1%. And then my right-hand side becomes 2,515.05. So it's bigger than what I need. So what I mean by linear interpolation is use my left endpoint plus, okay, so the right end value minus what I want divided by what I want minus the previous one times 10%, 10 minus 9. So basically what I did is this graph. So this is I, this is the right hand side. So when I try 10%, I have a number which is smaller than what I want. So when I put 9%, I get another number which is also not what I want, is bigger than what I want. What I want is here. So we do linear interpolation. So we draw a linear line to connect those 2 points, and this is what I get from here. So this is, but again, you know, this is a little beyond the usually what you need to do. So I do not require, as long as you can identify it is between 2 values, that should be enough. Okay, let's end here. We will continue to finish the SOA questions in the next video.